Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable. The function that's being given to us is y equals x squared plus 5 into log of 1 plus x into e to the power minus 3x, right? So it looks like this is a problem that will see the application of chain rule of differentiation. It will also see the application of product rule of differentiation. It will also see the application of sum rule in differentiation, right? So let's go about solving this problem. Y equals x squared plus 5 log of x into e to the power minus 3x. We know that the product rule of differentiation, we have seen this for, uh, you know, whenever it is a product of two functions u and v, right? And I want to draw your attention to the point that the same function, the same rule, the product rule of differentiation can be extended to more than two functions, right? And in this case, when we have three functions, right, the way we write this out is f dashed. If I'm going to treat my y equals f, right, what is my f dashed as per the uv rule? Let's write that quickly. And I'm going to teach you how we extend this identity, the product rule of differentiation, to more than two functions, right? And then we can solve this problem pretty quickly, right? So I represent my y equals f equals uv, right? And my f dashed equals uv dashed plus vu dashed, right? So that's what my product rule states. Now imagine if either u or v is a product of two functions within itself, right? So in that case, let's assume in the next step, let's assume u is equal to a product of two functions. And what do we call them? Let's call them, say, w and z. Okay, let's assume u is a product of two functions w and z. And remember folks, all these u's, w's, z's are dependent on the independent variable x, right? So what is my u dashed? I'm just going to expand my u dashed, right, in the same line. What do we get? So I have my uv dashed as it is, right? So what is my u now? My u is w into z, right? Where u is again a product of two functions. And then I go to the next part of my f dashed, which is vu dashed, which is nothing but v remains as it is. And my u dashed, again I apply the product rule of differentiation, but this time to this particular term wz, right? I'm going to highlight that in yellow. So what is my wz? Right, my wz is equal to u, and therefore my u dashed, again I apply the product rule and differentiation. That makes it wz dash plus zw dashed, right? So now you see, what do we get? We get our final expression is, if I have my f as a product of three functions, right, which is vwz, the way I arrive at f dashed is again very similar to the product rule when it comes to two functions, just that I can extend this to a finite number of functions, be it the sum rule or the product rule, right? So this is what I get. So my f, when it is a product of three functions, and let's say I replace my u as wz, let's say if my f is a product of three functions wz and v, what is my f dashed is nothing but wz into v dashed plus vw into z dashed plus vz into w dashed, right? So I keep function 1 and function 2, I differentiate function 3. Similarly, I keep function 2 and function 3, I differentiate function 1. And then similarly, I keep function 3 and function 1 and I differentiate function 2, right? So that's how we go about solving all these problems. So this example, what we have x squared plus 5 into log of 1 plus x into e to the power minus 3x is a problem where you will see the application of product rule for more than two functions, right? So let's do a simple application of the formula. So I have my three functions. What are those three functions? My function one is x squared plus 5, which I will highlight it in yellow. My function two is log of 1 plus x, and my function 3 is e to the power minus 3x, which I'm calling out in turquoise, right? So I'm going to write my f dash now in terms of these three functions, right? The product of my first two functions, right? I write them as it is. So this is what I have. Is I'm looking at this particular expression, right? Which is my, again, let me highlight it in yellow. So we are at wzv dashed. So I do a product of my first two functions, and then I differentiate my third function, which is e to the power minus 3x. And when I apply the chain rule, I will have to differentiate my minus 3x. So my dy dx of minus 3x is nothing but minus 3, right? So this is my first expression. Let me remove the color out here, right? So this is my first expression. And then we will move to our second expression, which is VWZ dashed, right? I'm going to highlight this in yellow again. What is my VW? My VW is a combination of the second and the third function, right? Written as it is, right? So let's copy that, and my z dash is d by dx of x squared plus 5, right? So d by dx of x squared plus 5 is nothing but, using some rule of differentiation, it's nothing but d by dx of x squared plus d by dx of 5. So my d by dx of x squared is 2x, and my d by dx of 5 is 0, right? So that's how I arrive at expression 2, right? So I'm going to remove the color, folks. And now we go to the third expression, which is my VZW dashed, right? E to the power minus 3x into x squared plus 5 written as it is, which is my third function and first function. And then I do a differentiation of w dashed, which is d by dx of log of 1 plus x, which is nothing but 1 by 1 plus x, right? And why is that? Because my d by dx of log of x is 1 by x. So my d by dx of 1 log of 1 plus x again is an example of chain rule and differentiation, where I do d by dx of the log function first. So I represent it as 1 by 1 plus x, and then I do a differentiation of the expression within the log in terms of x, which is d by dx of 1 plus x, which is nothing but uh, a 1, right? So this is my expression. I don't see an opportunity to simplify except that we can pull out my e to the power minus 3x, right? So let me open my big bracket, because I'm going to put all the remaining parts of the function into the big bracket. So I have e to the power minus 3x as common. So my first part will have a minus 3 into log of 1 plus x into x squared plus 5. So that is my part 1. And then I have my 2x dot log of 1 plus x, part 2. And my part 3 can be written in the form x by y, which is nothing but x squared plus 5 divided by 1 plus x, right? So that's how we represent our final answer. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.